without further ado, it is my great pleasure to introduce to you Mike McCabe from Cloud Security Partners, speaking on infrastructure as remote execution, practical use, Terraform, and LOCAL-EXEC.
Well, thanks everyone. Thanks for having me, and thank you all for coming out. I'll try to make this quick since I know you guys just came here for the tour and don't really want to listen to me talk. That's what I came to. So I'm talking about infrastructure as remote execution. This is about Terraform. So quick introduction. My name is Mike McCabe. I'm the president of Cloud Security Partners. We are a cloud security and application security consulting company. We work with a lot of different companies, large financials, small startups doing cloud security and application security consulting. So application reviews, cloud security reviews, architecture, pretty much everything under the sun. And I'm very passionate about this topic, and that's why I like talking to people about this. So what are we talking about? Who here is familiar with Terraform? The guy from HashiCorp passed to me. I had to change a bunch of my slides. I had so many things, so many bad things.
That was my demo when I started as an SE. I did it twice.
Yeah. Okay. So he knows about Terraform, but other people know about Terraform. Cool. Yeah. If you're in the cloud, it's a pretty popular platform. Won't have to go over the whole introduction, but if someone's not familiar, infrastructure as code is a way you codify your infrastructure into Terraform or CloudFormation, or if you use Azure, can we say that word here? Azure, use ARM or Bicep, or you can use Terraform as well. So what are the benefits of using something like Terraform? So from what I've seen, what we've done on projects with clients, one of the big things is you can centralize your deployments. So one problem people have in large cloud environments is what I like to call, I think Corey Quinn coined it as ClickOps, as in people going on the console, clicking around, deploying infrastructure, and doing it differently every single time. The problem with that is you get sprawl, you get things aren't named right, things aren't tagged right, things aren't secure. So you move to something like Terraform in order to have centralized deployments where you can deploy consistently, you can have tags, you can have naming, you can source code manage your Terraform so that it's not just kind of all over the place. And also you can apply security controls as preventative measures against that Terraform or CloudFormation or whatever it might be.
Oh, it works. Sorry. There you go.
Yeah. So what are some of the challenges? From our work, we've seen that people often give Terraform, whether it's open source or cloud or enterprise, they often give it highly privileged roles. People think CI/CD, give it whatever rights it needs to have in order to get the job done. That's a problem which I'll touch on later, but obviously it's a big issue when it comes to principle of least privilege. As I'm going to talk about, there's multiple ways to use Terraform to execute code. It's an infrastructure provisioning, not a code running tool, but there are ways to do that. It's also a really great way for attackers or malicious insiders to gather data about an environment. I'll talk about that. And there's also various ways to bypass security controls. So our experience in this is we've helped multiple people build out their infrastructure as code program. So that means moving from something like Service Catalog, AWS, into a centralized pipeline, moving to Terraform, moving to even just CloudFormation in their own pipelines, but doing it through a central service. We help build out literally thousands of rules against Terraform or CloudFormation or what have you to help secure deployments against different resources or account level checks, things like that. Against dozens of services and obviously thousands of users, because these are large financials that we've done a lot of this work with. And the reason that I like talking about this and why I want more companies to adopt something like Terraform or CloudFormation, whatever it is, as long as they're moving to infrastructure as code, is when you do this in a centralized way and you apply your security checks against it, you can literally have zero cloud security findings. And we did this at a large financial that we worked with where everything that was deployed through the central pipeline, through Terraform with the security checks in place, zero security findings. If anyone has a CSPM or Security Hub turned on, they look at their findings right now, it's going to be hundreds. That's just the price of being in the cloud. If you have dozens and dozens of services, you're going to have lots of different configurations. You're going to have a lot of misconfigurations, which leads to findings, which leads to cloud compliance teams spending all day chasing people down to fix stuff. So that's why this is a really great tool to use to actually secure your cloud infrastructure. You can also map those security controls to your internal and external, whether it's compliance guidelines or regulatory frameworks, whatever it is. So it doesn't just have to be best practices, but it can be your company's specific kind of secure requirements, which is great. So for anyone who's not familiar, this is kind of a general view of what Terraform would be deployed as. In this case, it's Terraform Cloud, which is their paid platform, which is cloud-based. They also have Terraform Enterprise, which you can run in your environment, or you can just download Terraform and run it as a binary, because it is open source. So what the general workflow is, someone writes Terraform, usually an app developer or DevOps. They commit that to GitHub or GitLab or Bitbucket if it's 1980 still. And then that gets picked up by the Terraform cloud or whatever pipeline you're using. And that's what actually reaches out and touches the cloud platform, whatever it is, AWS, Azure, whatever it might be. So that's the general workflow for how these deployments look like. It's very similar to an app workflow, except for you have this middle piece doing a Terraform kind of interpretation and provisioning. So how does
a question?
Yeah.
So in that graph, where does the security check done?
It would be right in the middle, in the Terraform cloud part. I'll kind of talk about that in a bit. So how does Terraform itself actually work? So there's two main components to it. There's a Terraform plan, which is when you write your Terraform, say it's an EC2 or something simple, you run Terraform plan against it. It basically creates a dependency map of what that's going to look like once it's deployed. It goes out to your cloud provider. It says, does this exist? Are these things there? Am I updating something? Am I destroying something? And it creates what's basically called a plan, which you can output as a JSON, and it shows you everything that's going to change. Once you accept the plan, sorry if you all already know all this, but I'll just go over it because it's important for other parts of the talk. But once you have the plan and you accept what's going to be created, updated, destroyed, whatever it might be, you have Terraform apply, which is when Terraform actually makes the changes. So that's when it goes out again to AWS and creates that EC2 or RDS, or destroys it or updates it, whatever it might be that you're doing in your plan, and it outputs those changes. So this is a really, really basic example of what Terraform can look like. In this case, all you're defining is a provider, which providers are what talks to the actual cloud, and then a resource, which in this case is an AWS instance, which is an EC2. And all you have to define is an AMI, which is the image to use, the size of the instance, and in this case, providing some tags, which I don't believe are actually necessary. But that's how simple Terraform can be, and you run this, you run a plan and apply, and it's going to reach out and set up an EC2 for you. So it's very simple. And this is what the plan looks like once it's run, even for that simple use case. And here's kind of a more zoomed in version. It gives you basically what's going to be created, what are the values that are going to be created. You can see some of those parameters there in the after block. So you see the AMI, a bunch of things aren't set. You can see a key name, you can see the instance type, security groups. All those things are what gets created, or what gets put into your plan to say what's going to be created or updated or associated once Terraform apply actually runs. And then once you have applied, you get to Terraform state. And state, as it's named, is basically a map of what your environment looks like right now. So it's a very large document that basically says, what resources do I have? What are their naming conventions? What are the configuration parameters? All of those things are basically in your Terraform state. The idea with Terraform is to manage your state so that it's not drifting and you said, I want this, and then it eventually becomes this. Terraform helps keep everything together by basically saying, here's what we think it should be. Let's check when we do a plan to see if it's changed, and we'll tell you basically if it's different. I don't think they have drift detection right now like CloudFormation does, but I think that's coming. But one security issue with Terraform state, if you can see in this case, this is an example where there's a key in state. So when you create something like an EC2 or a key or an RDS instance that has a master password, all of those things have to be in the state because Terraform is managing them. If you want it to update a value, it has to have that value in order to update it. So this becomes a huge security issue because your Terraform state file is now basically your secrets manager. And a lot of people don't treat Terraform state as if it is your secrets manager. But if you're using it to create secrets, literally in secrets manager, it now has a copy of those. And there's been multiple cases where attackers will actually get into an environment, they'll find a Terraform state file either in S3 or on a EC2, wherever the company is hosting it, and they'll skim through it, find secrets, and use those to pivot elsewhere. I'm sorry for that person or HashiCorp here, but this is a funny GitHub issue which is about storing sensitive values in Terraform state. So it might be hard to read, but it was open in 2014. And the last update from, hopefully you're not Omar, but Omar from HashiCorp, which was about 3 weeks ago, was like, hey, we're still working on this, we're still prioritizing it. Give us whatever that is, 8 more years, and we'll get around to it. But no, I mean, it's a hard problem to solve because, again, you have to have the values there in order to manage them, so it's not as easy as just kind of removing them from Terraform state. But the issue is when you have a Terraform implementation, open source, cloud, or enterprise, you have to think about how you manage state, and you have to treat it like it's a very sensitive thing because it is. Have to have one meme per talk. Good. One meme. Another thing that makes Terraform complex, I kind of talked about Terraform providers. So for everything you want to manage with Terraform will have a provider. You can create your own providers. HashiCorp has a lot of providers they provide, obviously for AWS, for Azure, for GCP, and a lot more services than just that. So they give you a lot of providers to use out of the box that work really well. But when you think about the supply chain, we talk about people having issues with NPM libraries. In the AppSec world, it's a huge issue with people having insecure libraries or name squatting libraries. Now, in the infrastructure side, we have to think about that too, because we're trusting a lot of code from HashiCorp. We could be trusting code from the community. We could be trusting code from any random GitHub that you find and decide to use a provider from, which you think doesn't happen, but happens a lot more than you hope. So we're introducing all of this code into our environment as well. So we have to think about what's our kind of plan to manage this code? How much do we trust it? And on top of that, all of these providers open up new APIs for you to use within your Terraform code. So if you're a security person trying to create a secure Terraform implementation, you have to think about all the providers, all the APIs in that provider that you now have to think about. And in the work that we've done, this has been not a nightmare, but there's a lot of research that goes into figuring out what you can do in Terraform and then restricting that so people can't abuse it. So on top of that, if I've made a bad enough case for something that I actually do support and think is a good thing, Terraform also has APIs if you work in the cloud or the enterprise side, where you can update your workspaces, you can touch the state, you can view the state, you can update variables. So there's another kind of threat surface you have to think about when it comes to Terraform. And one more bad thing, then I'll go on to some other things. But Terraform logging is another area where when Terraform does its work, it has to go out and assume a role in, say, Amazon or whatever cloud provider. It needs credentials locally in order to interact with that cloud provider. Those credentials, if you turn on verbose logging, which is just a variable in Terraform, get dumped out to the console. So in this case, what I'm showing is basically when Terraform is assuming a role, you can see the STS session, which is the assume role session from AWS, gets dumped out into the log. So again, if you're in an enterprise trying to implement these kind of things, you have to think about, okay, even our logs could have sensitive data. If a developer, malicious insider, or attacker is able to basically turn on verbose logs, do an assume role, dump that session out, and then start using the Terraform role themselves. So just one more kind of attack surface that we thought about and had to deal with in our work. this is not quite a meme, but close enough. So Terraform is, for use with competent users, which means you have to think about kind of how you're going to use it, how you're going to implement it, all of these attack surfaces that we've kind of covered so far. So what I'm going to talk about tonight in particular when it comes to some techniques you can use to actually execute code with Terraform that are other areas that attackers or malicious insiders can abuse, are a few of these. Speaking of AI can't do fingers very well, so you can tell that that's a mid-journey generated image right there. So there's some weird hand things going on.
Was the prompt, was Bruce Lee in the prompt?
Yeah, I got that part right, just not his hands. So the first one I'm going to talk about, it's called REMOTE-EXEC. Anyone familiar with this who's done a lot of Terraform? No? Okay, good. Learn something new then. So as I said, Terraform is an infrastructure provisioning tool, not a, it's not an Ansible, it's not a shell script, it's not a end instance provisioning tool. It's not what it's meant for. It's meant to do, set up the EC2, not to configure the EC2. There's a lot of good tools for that, like Ansible, Chef, Puppet. Those are all very well-known tools that are meant for those kinds of things. But Terraform does give you the ability to actually do that, and that's through something called REMOTE-EXEC, which, as its name, is remote execution. And even HashiCorp says this introduces a considerable amount of complexity and uncertainty. So basically, don't use it. So what this gives you the ability to do, this is some sample Terraform, is if I was an attacker and I was in an environment where I couldn't get onto an EC2 in production because, if you're a well-run enterprise, you don't give people SSH access to production environments, you don't give them shells, and there's very limited kind of ingress and egress out of it. I can run some Terraform to create an EC2, and then I'm not sure how many people are familiar with Netcat, but it's basically a very simple network tool that creates tunnels. So if you can't SSH out, and you can't do like a more robust protocol. Netcat is a very simple tool to use to basically create a reverse shell or a shell into a place. So you could do something like create an EC2, and then use the REMOTE-EXEC provisioner at the end of it to Netcat out, create a reverse shell. So you're not creating something into the environment, you're creating a shell out, and then from your C2 command center, you can then interact with that EC2. For startups and people who don't have a super robust security program where they limit access to production a lot, this might not be relevant because you're like, they can do whatever they want to do. We have no controls. But if you're a SOX company, you have to have privilege access management in place. People have to have approvals, change tickets to get into production. This basically bypasses all of that just by having the ability to run Terraform. That's one of the techniques. And then another one, very similar, LOCAL-EXEC. Remote is remote, local is local. So this runs actually on the same machine as where Terraform runs. So if you're using something like Terraform Cloud, it's going to run on the Terraform Cloud instance. If you're running an EC2, it's going to run there. Pretty much wherever Terraform itself actually runs, this will run. So why is that an issue? Again, you're introducing code into an infrastructure pipeline, so shell scripts, just simple bash scripts, PowerShell, whatever it ends up being, you're now adding that level of complexity, and you can't do the same things security-wise with what we're going to talk about with shell scripts. It's just a different language, different protocol. And like I said, Terraform is often given highly privileged roles in an environment. So if you're giving it administrator access policy and you're saying it's CI/CD, it's got to do what it's got to do, anyone who has access to that role or the session is also now an admin access. Again, if you don't have a lockdown kind of IAM in your cloud environment, then this might not be relevant, but eventually you'll get to that place where it is. So LOCAL-EXEC will run on the instance running Terraform itself. So again, you can run things like shell scripts. In this case, I'm curling the metadata instance. Is everyone familiar with the metadata instance? Yeah, so the loopback interface that EC2s use to get the temporary credentials for whatever role the EC2 has. In this case, curling that, getting the temporary credentials, and then curling that out of the environment. So the idea being, run this, it'll grab the Terraform role session for whatever role Terraform has itself, and then exfil that out. Sorry for the HashiCorp person again. I was testing on Terraform Cloud, and for a while the metadata service was actually turned on there too, and they recently turned that off. So for a little while you could do this on Terraform Cloud, but they fixed that. So it's a big issue because, again, if you over-privilege Terraform, and we see this often, and then you don't lock down these kind of abilities, any developer can just abuse this to get that access. Or if an attacker has access to your pipeline or a malicious user, whatever it is. So it's a pretty, again, it's another kind of way to execute arbitrary code. So I always like talking about solutions. Is anyone familiar with SemGrep? Okay, learn something new again, great. So people will probably use some AppSec. Yeah.
So since these two examples are actually anti-pattern,
yeah,
is there a way to just turn them off?
I'll get to that. Turn it off, no. Prevent it, yes. Like there's no way in Terraform itself to just say like don't allow that kind of thing. They're actually built into the core Terraform API, not like a provider API. So even if you didn't use the AWS provider, you still have these.
You should really make it configurable.
Yeah. You can put support requests from there. So SemGrep, people know what grep is, right? Okay, good. SemGrep, semantic grep, is it's an open source, they also have a paid product, but there's an open source version. It's basically trying to make security of code more simple and more straightforward. So if anyone has been doing AppSec for a while, the tools get massive, they take days to run. I do a lot of AppSec work, I don't like most tools. The point of SemGrep is to basically make it really simple. This is not a paid endorsement, I just like the tool. And they're really easy rules to write, so if you have some pattern you're trying to check against, it's easy to write them. It's also fast, which is important if you're going to put anything into a pipeline, and there's a bunch of open source rule sets. So I don't know if you guys can read this, but on the left, you have your SemGrep rule, and on the right is the example Terraform. So I can zoom in. It's still kind of small, but really what matters is line 4. So you can just create a simple pattern. Again, it's like grep. With grep, you're looking for patterns. Here, you're looking for patterns too. You say, I want to look for the pattern provisioner, anything. I want to say any provisioner, which would be local-exec, remote-exec. There's other provisioners too. It's like find that case and fail if you see that case. And that's as easy as it gets with SemGrep. You don't have to do much more than that to have SemGrep catch these kind of cases. So for what you're saying, what you want to do is either in your CI/CD that runs against your code base that has your Terraform in it, or in Terraform Cloud, or in your Jenkins pipeline, wherever you run Terraform, before it actually gets run, you run these SemGrep rules to break the build, more or less. So there's no great way to disable it, but you can use these simple rules to prevent it. I'm running through this pretty quick. Any questions before I move on to some other topics? Yes.
Throw one thing in about the remote exec. One of the things that you can do with Terraform Cloud, Terraform Enterprise, is you can run your own Terraform runners. Then you can control what image is used to run that environment. So if you change it to say, you know, this container doesn't have anything but this restricted set of binaries, then they won't be able to local exec something that's not there.
Yeah, sure. Yeah, with runners, you can, Terraform Cloud or Enterprise, you pick your runners. You can put it on like a super lockdown image that has nothing on it. So it's definitely possible, but unfortunately not everyone does that.
Right.
But so that's some of the code execution methods. From a data gathering and some other kind of code execution methods, I'll cover some other things that you can do. So in Terraform, there's resources, which is something like an EC2 and RDS, whatever. Then there's data. Data is kind of a static lookup of, say, an SSM parameter, a secret from secrets manager, even an HTTP call. In this case, this is using the data, the HTTP data type, which, again, I'm using the metadata instance metadata example, because that's in AWS a really powerful way to get credentials. And just doing a data lookup against that URL will then dump out that the response from that HTTP endpoint, and then in your logs you'll see your STS role. So again, like I said at the beginning, Terraform itself is a pretty large attack surface. Providers add more, but even in the most basic use cases, we have things like the HTTP method that you can use to dump out that role session. So again, you can use things like SendGrep to prevent this, but just one more thing you have to think about when you're designing a Terraform pipeline, or anything. But
Quick question, please.
Yeah.
So how would you, what would the SendGrep look like for that previous screen?
I'm not sure if I have a slide, but it would literally be data and HTTP. So I think I have a slide that shows it, but
Can you use that for a benevolent purpose?
yeah, I mean it's restricted to GET requests, so it's not super useful. So you have to have another HTTP endpoint that doesn't have authentication on it. There's other methods you can use if you want to make remote calls, like Lambda invocations. So we've done that with certain things. If we need data at runtime, we'll use like a Lambda call, provide variables, and that will give us back information.
One thing I use it for all the time is when I'm running Terraform and I want to allow the machine that I'm on to have access through the security groups to the environment that I'm building. I'll put in a call to HTTP to something like icanhasip.com, fetch my local IP, and then create that as a Terraform local, and then plug that into the security group rules so that my laptop then can access the environment that I'm building in AWS or wherever.
Gotcha. Yeah, that makes sense. Yes, I mean there are some use cases for it, but again, I mean from a paranoid security perspective, it's definitely one you have to lock down. You can make arbitrary HTTP calls with it. You could do something like server-side request forgery, but it's a very limited HTTP request. It's not a full post request with the body and everything like that. So hopefully they don't introduce that, because eventually if they introduce a more complex HTTP provider, IMDS v2 would stop working, which is the prevention you use in EC2 so that people can't hit this metadata service. So you can see in this case, this is a Terraform plan. The fun thing about this, I'll talk about this a little bit more, but again, like I said, plan and apply. If you have your security tools running post-plan, which some do, this would not prevent that. So you have to have it pre-planned, because data calls are done at plan time to be included in the plan for when you apply. Hopefully that makes some sense. But basically, this is an example of using that to dump out, again, that SCS session for the Terraform runner. And here's the SendGrep rule here. You can make this more specific to just be the loopback address. You don't have to make it, just basically blocking data HTTP. But this is
Can you whitelist instead?
You could, yeah. You can have variables in SendGrep rules. So it's really easy with these tools to stop this kind of stuff. So here's a fun weird edge case, which there's another data provider called external data in Terraform, which even though it's data, it's actually a way to run scripts. So in this case, you can point it to a Python, you can point it to a shell script. You can point it to a shell script. In this case, it's a Python script, and you can pipe data into it. So in this case, I'm using a data call to call the secrets manager, grab a secret, and then hand that into the Python script, which you could do whatever you want at that point with that. You could exfil it in some way. So even though it's a data call, it's actually running code. So SendGrep is great for really basic use cases. It's a really powerful tool, but if you need to build more complex rules to do more logic or kind of data management, you have to move past something like SendGrep. If you want very specific checks that you don't want to just build regexes for, you have to move to something a little more complex. So there's a couple tools that we've used. HashiCorp Sentinel, which is a paid tool from them that's built into Terraform Enterprise and Cloud. And then OPA, anyone familiar with Open Policy Agent? People use Rego, anything like that? That's an open source tool. OPA is kind of a whole framework for writing rules, not just for not just for Terraform, but for any language basically. So it's a pretty cool framework for writing security tools against a lot of different stuff. I have more experience on the Sentinel side, so I'm talking more to that. But they're both tools that are out there for more in-depth testing for Terraform. Some of the benefits of these tools. So again, we get to policy as code. We write code to enforce our policies, our security requirements. They're very fine-grained. It's embedded. A nice thing you can do with all these tools is have different enforcement levels. So certain things are hard mandatory, and they break the bill. Some things are just advisory. And Sentinel and OPA are both multi-cloud. So what does a basic Sentinel example look like? This is less than 16 lines of code. And what we're doing here is we're defining some EC2 instance types that we want to allow. We're going into our plan, like I talked about before, finding the EC2 instances, and then doing a comparison to basically say, is there anything that is not of that instance type, and then failing if there is. So this is a really simple Sentinel rule that basically prevents people from provisioning any resources that aren't on the type that you want. This one's a little more complex. This is enforcing a role in a provider. So it's slightly more complex than the other one, but again, it's less than 29 lines of code to ensure that the right role is assumed in your by your provider. So it's not a huge framework that you have to learn. It's not a very complex language specification. It's pretty simple to get started. So it's a good way to start writing security rules for your Terraform to prevent some of these things. But there's always a but. When we talk about Terraform plans, it's calculating that whole dependency tree. It's saying, here's what is now, here's what's going to be. So one thing it can't detect or determine is things that don't exist and what those dependencies might look like in certain cases. So Terraform does something called after unknowns, which is basically, here's the things we know, here's the things we're going to create, here's all the things we don't know what the values are yet because they're not created. So think of it like if you have something pointing to an SQS queue, but you're also creating that queue, the ARN for that queue is after unknown because the queue has to be created and the ARN is known, then it's used in that other dependency. The issues that this creates when you use something like Sentinel or OPA, a post-plan tool, is that anything that you can make after unknown then bypasses those security checks. Again, sorry, HashiCorp, but this is something that we brought to them and they didn't have an answer to how you prevent this because it's just kind of built into how Terraform works and how it builds its trees. So you have to have explicit checks to basically say you can't allow whatever parameter that you're checking, if it's a security group or whatever it might be, a naming name, you can't allow it to be after unknown. So you have to go into the after unknown block, see if that value is true, and basically say, no, you can't allow this to be after unknown. If you don't, and you allow it to go through, you can write Terraform, not in every case, but in certain cases where you can force the value to be after unknown and just bypass that security check. So that was a fun edge case that we found with one client. So another thing to kind of think about. So that's all the bad things. That's all the bad things. And I'll always say that I'm a big fan of Terraform. I'm a big fan of infrastructure as code, but there are a lot of things you have to think about when you're using these tools and building a program around it, and especially if you're a high security company, well regulated, well audited, things like that. So what are some of the solutions to address some of these issues? I talked about a little bit of this, but I'll kind of dive into each one. IAM. This is kind of your baseline way that you prevent some of these issues. So the big thing is don't give your pipelines, no matter what it is, CloudFormation, ARM, Bicep, Terraform, whatever it is, don't give it high privilege roles. People get lazy, just like click admin access to a role, and they can do whatever they want. So build roles policies for your pipelines for what they actually need to deploy. don't give it everything. If you're not using EKS, don't give it EKS. If you're only doing EC2 and S3, give it access to EC2 and S3. If you're not managing IAM through your pipelines, do not give it access to IAM, because someone can easily just change or create new policies, create new users, things like that. And then once you have kind of that well-rounded, well-thought-out policy or role, you need to monitor those changes as well. There's no point in having a great IAM policy or standard, and then you do it once, and then things change, and you can just get role or policy creep. That's something that we see all over the place, and so you have to monitor your IAM permissions as well.
Quick question, please.
Yep.
The problem is in a large enterprise,
Yep.
if you're using a unified pipeline, you have different teams who will be deploying to different services.
Mm-hmm.
So even applying the least privilege will have so much privileges.
So this was really dependent on your IAM kind of how you do it, but you can actually have a role per app team. This is how we've done it with places where you can basically say, this is your app team, and you can use like resource naming conventions to be your guardrail, or tagging is another way you can do your guardrail. So if you have app-specific roles that they're supposed to assume, so they can only touch their EC2s or their data, you can do the same thing in Terraform. Basically say, in this workspace, you can only assume this role. Or you can use something like semgrep or Sentinel to say, for this workspace, for this Jenkins, whatever it is, use the metadata of the environment and say this provider can only assume this role, which is guardrailed by conditionals on resources, resource names or tags, things like that. So yeah, smaller companies will just be like one role for all of Terraform. Larger companies get into especially if you're SOCs and you can't have apps talk to other apps, get into those like app specific or team specific roles. And you can do the same thing with semgrep and with Sentinel. So yeah, it becomes a little bit of whack-a-mole to like close off all those areas, but yeah.
I just wanted to add, do look up IAM guardrails that he's mentioned a few times. That gives you just bigger discussion than you probably want to pivot to, but it's worth understanding what the guardrails are, because that'll give you a lot where you can have those roles restricted with what they can do. And then, as you're saying, the individual roles, it's not very hard to have individual roles. It's a setup, right? But once you have them, it's not hard to use in whatever pipeline you use.
Yeah, I mean, you can use Terraform itself to define your policies, your roles, and then also use Sentinel or whatever tool to define what those things can have. So if you see S3 star pop up with no conditional, then like fail that Terraform deployment, there's an issue there, kind of thing. So, and yeah, there are a lot of conditionals in IAM, what VPC, what EC2, a lot of things you can do to limit where these roles can be used as well. So it's definitely getting better, but IAM is probably still the #1 headache. When we do assessments, the first finding is always mismanaged IAM. So patterns. A lot of places might not have dedicated architecture teams or dedicated architects, but we've done a lot of work with people who do kind of go through that pattern to implementation process. And even if you're a smaller company and you just Jira tickets straight to code, even if you're that smaller company, having patterns for what you want to build and then having your defined guardrails part of that is pretty huge. We always laugh when we go in to do an architecture review because no one has an up-to-date architecture diagram where they say, here's the architecture diagram, and it's like a 2003, last modified. So a lot of places struggle with this, but it's really important for either it's app services or cloud services to have patterns for how you want to adopt it. And then those guardrails that you define end up being things like Sentinel rules, semgrep rules, whatever it might be. So it's really important to have those patterns in place as your baseline. And as those patterns, you build hardened services as a part of that. So for instance, with one of the clients, we have, I think it's around 40 rules just for RDS. And so when an RDS instance goes through Terraform pipeline, we make sure that 40 different things are checked for it. And what comes out of it is basically a hardened version of RDS. So it's not what you get if you just go to the console and create an RDS. And so having those patterns and having those kind of hardened versions of those services is important. Code review, I've kind of harped on this quite a bit, but having SemGrep, having Sentinel, having, there are other tools, Checkoff is one, TFSec is another one. There's a lot of tools out there. I like SemGrep because I feel like every company, if they get big enough, they're going to have a security engineering team that's going to be doing this stuff. Out of the box tools are good. They have rule sets that they're just very generic, and so eventually you're going to have to customize it to your use case. So starting with SemGrep and building your own rule set makes a lot of sense to me. But there are tools out there that are useful to get started with. And you should use these tools to enforce not just security things like S3 not being public, but you should use it to enforce tagging standards. You should use it to enforce naming standards, all those types of things. So don't think of it as just security. Think of it as across the board compliance and
Question.
Yeah.
So there's lots of tools out there. Can you give a few examples of that?
TFSec is an open source tool from Aqua Security. So it's just a thing you run next to Terraform. And it actually uses OPA under the hood, but it has a bunch of default rules to check for things like public RDS. It's just it's very best practice focused. It's not a hugely in-depth tool. None of these tools actually have rule sets for some of the patterns I talked about. I have some SemGrep rules on my GitHub for this stuff, but it's mostly best practices from AWS, so from the public RDS, encrypted resources, all that kind of stuff. So it gets you something out of the box, but it's just not very in depth. So monitoring. You definitely want to monitor IAM changes for your CI/CD pipeline roles. Those are changing a lot. If they're expanding, then you know something's probably going wrong. So definitely have monitoring for that, but also look for changes in what Terraform itself is deploying. So something that we do is we use a cloud tool to basically see all the resources that Terraform deploys based on tags, and we know, okay, if it's in a region it's not supposed to be in, if it's a resource that's not supposed to be there, something is wrong. We have to find what issue to fix that.
Okay, thank you.
Cool. So conclusions, despite all the negativity, I actually am a huge fan of Terraform. I think it's a great tool to use. It's a super powerful way to standardize how you do cloud deployments. And it's a really great integration point for security for things like SemGrep or Sentinel, whatever it might be. And so I definitely encourage you, if you're doing ClickOps right now, move to something like Terraform or CloudFormation. I won't get on AWS. But there's a lot of things you have to think about when you do this kind of work and when you do a whole program around it. So that is me. If you want to hear more of my rantings about this and other things, I'm on a podcast with another guy relating to DevSecOps. It's not all ranting. And if you want to talk more about cloud security or infrastructure as code or anything, you can reach me at mike@cloudsecuritypartners.com.